Okay, so the only problem-solving request was for some 3.2 problems, which we only had the one that was actually collected, and I worked through that other example in class on Wednesday. And I had asked for some clarification, but I know that the discussion board is not instantaneous. So my best guess is that the request was to go through this participation problem. Sorry if I misunderstood, but I'm going to go ahead and do this one, and hopefully it's helpful, and that this is the section you were looking for. So the section 3.2 was all about that reduction of order stuff. And in this problem, we're trying to solve 9y double prime minus 12y prime plus 4y equal to 0 with the knowledge that y1 is a solution to the equation given by e to the 2x over 3. So our approach for these reduction of order problems is always to assume that the second solution, y2, is some unknown function u times the first solution we were given. And so in this case, it's going to be some unknown u times e to the 2x over 3. And then just like most other methods in this section, once we have that assumption of what we think the solution will be like, we're just going to go ahead and plug it into the ODE and figure out how to make that true. So if y2 is u e to the 2x over 3, I'm going to need to know its derivatives to plug it in to the ODE. So y2 prime is going to be, maybe I take the derivative of u and leave e alone, or I leave u alone and I take the derivative of e, like that. Remember that u is an unknown function of x, and so we do need to use the product rule here. That's kind of the main way that people make mistakes on taking the derivatives in this section. Then to get the second derivative, we just go ahead and do the product rule twice to both terms. So I'm going to take the derivative of u prime to get u double prime, and leave e as written. Or I'm going to leave this u prime here alone and take the derivative of the e to the 2/3 x. And then turning to the second term, I might take the derivative of u and get u prime 2/3 e to 2x over 3 unchanged, or leave u as it is, take another derivative of that exponential, like that. And so simplifying all of this, I'm going to have u double prime e to 2x over 3 plus 2 of these gives me u prime e to 2x over 3 times 4/3. I don't know why that showed up just now, or how to make it go away. There we go. And then 2/3 times 2/3 is 4/9 for that last term, u e to the 2x over 3. Okay. So now that we have all the derivatives, we can go ahead and plug into our ODE. 0 equals 9 y2 double prime minus 12 y2 prime plus 4 y2. And we're going to get 9 times that u double prime e to 2x over 3 plus 4/3 u prime e to 2x over 3 plus 4/9 u e to 2x over 3 minus 12 times u prime e to 2x over 3 plus u 2/3 e to 2x over 3 plus 4u, oh no, I thought I was going to have enough room, but I was wrong. All right, plus 4u e to 2x over 3. And it's just going to be a little bit of algebra to start simplifying this. So we're going to have E to 2x over 3 is in every term, so I'm going to pull it out to start to give myself a bit more room to write. And then I've got 9u double prime plus 9 times 4 over 3u prime plus 9 times 4 over 9u minus 12u prime minus 12 times 2 over 3u plus 4u. And since this is all equal to 0, I can actually get rid of that e to 2x over 3. You can think about it as, for this to be equal to 0 all the time, I need the thing in brackets to be equal to 0. You can also think about it as dividing that e from both sides. So I've got 9u double prime plus 3 times 4u prime plus 4u minus 12u prime minus 4 times 2u plus 4u. I'm just dividing out these fractions here to make it a little easier on me. And hopefully this is the point where we start to see the reduction of order actually happen, where the lowest order term u drops out. If you don't get u going away after this step, it usually means something went wrong in your product rules or just the algebraic simplification here. And you can roll back and make sure it happens. So let's see if it worked out for us here. We've got 9u double prime plus 3 times 4, 12u prime minus 12u prime. So in this case, that u prime is also going to go away, although it doesn't always have to. Plus 4 minus 8, so there was my 4, here's my minus 8, and then here's another plus 4u. And so I'm going to have that both these terms go away. So I'm left with 0 is equal to 9u double prime. And it actually doesn't even matter that that 9 is there. Same way I divided out that e, I could also get rid of that 9. So it's actually just that I have 0 is equal to u double prime. You don't have to take that extra step, it just means you have one less number kind of hanging around as you work through it, which I like. And then this is the part where we assume that w is equal to u prime, so w prime is equal to u double prime. So we got rid of the u as we needed, and then in this step we introduce that variable w so that we take ourselves back to a first order problem that we know how to solve. And in that case, we're left with the equation 0 equal to w prime. Or 0 equal to dw dx. So the thing that happened when you all were working on this is if you had the reduction of order formula down, or sorry, method down, but got to this point, it could be kind of intimidating, like it looks like there's nothing for you to do. It's because this problem is sort of deceptively easy. It's so easy it made you all overthink it. But once we get to this point, we can go ahead and just solve this like a separable equation, even though it looks a little bit silly. So we could say, okay, 0 dx is equal to dw. We integrate both sides. I'm going to get w on one side, and then the integral of 0 is just a constant. Because sort of if you have any number, when you take its derivative, that constant number goes away. And then once you've solved for what w is, usually it's a little bit more complicated on this side, but for us it's not. We want to find u in the end. So since we assumed w was the derivative of u, we can go ahead and integrate w to get u back. So we're going to say, okay, u is the integral of w. which is the integral of some unknown constant with respect to x, which is going to be whatever that constant is times x. So at this point, we know what u is. It's something times x, and we wanted to find y2. So we're just going to go ahead and plug back into this formula right here where we assumed that y2 was u times e to 2x over 3. Or it's going to be cx e to 2x over 3. And that's actually as far as this problem went. You do have to choose some non-zero numerical value for your constant because WebWork can't grade it otherwise, so I'm just going to choose 1. And I see that that answer is correct. So I took c equals 1. If you wanted the general solution, it's c1y1 plus c2y2. So it'd be c1 e to 2x over 3 plus c2 times cx e to 2x over 3. And we can only have two unknown constants, so you would want to combine these into a single number. That I called c2 tilde just now. But that would be the general solution to this ODE, and you all actually already know from the constant coefficient section that if you had gone ahead and used the auxiliary equation, you would have gotten that general solution. This is a repeated root problem. So that's the general approach for the reduction of order. The thing to just be careful about is that u is a function of x, so you need to use the product rule. At least u should drop out of your ODE down in this step. In this problem we had u prime go away, but that doesn't usually happen. And then after you get to the point of solving for w, just undo everything that you assumed to start the problem. So integrate to get back to u, and then plug into y2 to get back your solution.